You built dashboards, alerts, and notifications. But what happens when there's not just one service, but 10? Welcome to production scale monitoring. In this final episode, we will take everything we built so far and expand it into a real world setup, a web front end, back end API, and a database. All monitored, all alerting, all visualized together. This is where your observability system evolves from a side project to enterprise grade scale. In the previous episodes, we have mastered Prometheus, Alert Manager, Grafana for a single application. But in real companies, it's never one application, it's many different services talking to each other. So today, we scale our entire design to handle multiple layers, just like a real production environment. Before we dive in, make sure you hit subscribe. This is the series finale, and what we are building today mirrors exactly what real DevOps engineers deploy in production. Now let's jump into our Visual Studio Code. In my Visual Studio Code, I have episode 10 enterprise monitoring folder. In this folder, we have the exact same stuff which we had in episode 9 with some more additions. First, let's start with docker compose.yaml. So far, we only had one service. Now we are going to add another service, API service, followed by we have a database tier wherein we are trying to start DB as well. Then we have DB exporter, and in the end we have our monitoring stack: Prometheus, Alert Manager, Grafana, Node Exporter. These are all the same stuff which we were doing from episode 1 till 10 so far. Now, Prometheus will monitor all three layers and Grafana will tie them together visually. Now let's jump into our Prometheus folder. In Prometheus folder, I try to add a second job named API. Target would be API 5001 port, and another job is Postgres DB exporter 9187. This node exporter, we already have that from the beginning. Now let's jump back to docker compose.yaml. I would like to give a small explanation about DB exporter. What exactly is this? This exposes metrics like connection count, cache hit ratio, and query time on port 9187. Prometheus picks them up automatically. Our web has a slash metric endpoint, and also our API has a slash metrics endpoint. Just like we did earlier with Flask, in large systems, each service owns its own metrics endpoint. Prometheus simply scrapes all of them, making it effortless to scale from 3 to 300 services. Now let's look at the alert rules. I am trying to add two more alerts here. They are almost similar to the first alerts. The names are a bit different and also the expressions are a bit different. This gives every layer its own alert logic, all funneled through the same alert manager to Slack pipeline. We need a Docker file as well on each service. For example, API service will have its own Docker file, followed by database service will also have its own Docker file, and then web service will also have its own Docker file. I'm not going to explain everything in detail because I already did that. If you are new to my channel, please watch my Docker full course where I explained each and everything in detail. Alright, now let's try to start our stack. Docker compose up build-d. Press enter. As soon as I start, you see all the containers are, let's say, starting. API, web, alert manager, node exporter, DB exporter, Prometheus, Grafana. Now let's jump back to the browser. I can see a new login page here. So let me log in real quick. I'm going to log in and skip this. We do not have any kind of dashboards in place. That's expected. First of all, I would like to add a data source real quick. Add data source. Select Prometheus. Scroll down. And here Prometheus colon 1990 port. Followed by, I'm going to save this. As soon as this is done, we are jumping back to our dashboard panel. Now the fun part, building our multi-service Grafana dashboard. First, create a dashboard, add visualization, select Prometheus. First, I would like to start with application errors. For that, I would say give the title as app errors. In the query, I would say increase app errors total job is equal to web 1 minute. Followed by, we are going to add threshold value as well. Let's try to add some values here. 1 means it would be green. Everything is working fine. Base value, let's put it as 0. I'm not going to show it for each and every panel. I hope you guys understand what I'm trying to explain here. So let's try to save this dashboard. Name it as multi-service dashboard. Save this. Right now we are on multi-service dashboard. So I try to add a web service panel. For that, I would say add a row and I would like to give a title name here. What exactly is this? Web service update. So you will see web service related stuff in this particular web service row. Followed by, I would like to add another visualization real quick. So this time it would be uptime title followed by job. I'm going to add PromQL query up job is equal to web, and the same goes for the colors. Green would be number 1. If anything less than 1, that would be red color. Save this dashboard. Save. Go back to the dashboard. Now if we check, I have uptime. Now we have uptime dashboard in the same web service. And also I have application errors. So let me place it next to each other. We have web service in place. Now let's try to add a new visualization. So this time we are going to say API errors. So I would like to write title as API errors, followed by increase app errors, followed by increase app errors total job API 1 minute. I'm going to save this dashboard, save, back to dashboard. Right now it doesn't have any kind of rows. Let's try to add a row real quick. So I would like to give the title as API service update. And let's try to add another panel here. So that would be our response time. So title would be response time, followed by we'll add a query, app request latency seconds. Then save dashboard, save, back to dashboard, and then under API service we'll have, now each service has 2 panels. API service has response time and API errors, whereas web service has uptime and application errors. Now let's try to add another visualization. So that would be our connection count related to database. I'm going to give the title as connection count, followed by pg stat activity counter data name. That is that name that is equal to DevOps. I would like to save this as well. Back to dashboard, and then I would like to add a row. So row title would be our database service update. And let's try to add last panel here. So that would be the uptime of the database. I would say uptime, and the query would be up job is equal to Postgres. Okay, let's give it a gauge here so that we'll see some changes. And also let's change the value here. 1 would be green, 0 would be red. If it is down, we'll see red. Now let's try to save this. Back to dashboard, and let's try to move this into the database service. Overall, we can see multi-service dashboard, database service, API service, web service. Now let's try to trigger a simulation. For that, I'm jumping back to my Visual Studio Code. Now let's try to simulate some errors. For that, I am going to say docker execute -it and try to create a file. Followed by, I would like to do some curl request. As soon as we do this, let's jump back to our Grafana dashboard. Here we have different services. I see no issues here, and also I do not see any kind of errors. And if I go to web service, so if you see our application errors, I see different lines here, yellow, red as well. If I go back to my application errors, here I selected some of the options here. For example, show thresholds as lines, as filled regions, as lines off. I mean, we have multiple options. Based on the requirements, we can select all these options. And also I updated from green to red. Previously the base was red, so I updated back to red and green. And yellow one is, let's say, one error would be yellow, kind of a warning which we have. Save the dashboard. And just like that, from episode 1, no monitoring panic, to this moment, we've built a production grade observability stack. Prometheus collects, Alert Manager decides, Grafana visualizes, and Slack communicate. Together, they form the backbone of real DevOps monitoring. This isn't a demo anymore. This is how actual companies run observability at scale. Thank you for following the entire series. If you learned something valuable, drop a comment, share it with your team, and tell me what simulation you want next. And remember, observability isn't about tools, it's about understanding your entire system in one glance. Thank you for watching, and see you in the next video.